In the 1960s, 4 American companies controlled the earth-moving equipment market in roughly equal share: Caterpillar, International Harvester, Euclid, Allis-Chalmers. All 4 of them fed their biggest machines into the largest construction project the world had ever seen: 41,000 miles of interstate highway across 49 states. The concrete alone could build a wall 9 feet thick and 50 feet high around the entire equator. By 1992, when the last original mile was finished, 3 of those 4 companies had been sold, broken apart, or erased entirely. Only Caterpillar walked out alive. This is what happened inside that project, and why it killed the companies that built it. To understand how the interstate highway system came to exist, we need to go back to the summer of 1919. A 28-year-old Army officer named Dwight David Eisenhower volunteered for what he later called a genuine adventure. The United States Army was sending a convoy of 81 military vehicles from Washington, D.C. to San Francisco to test whether a motorized column could cross the country under wartime conditions. 258 enlisted men, 24 officers. A fleet of Harley-Davidson and Indian motorcycles ran half an hour ahead as scouts, painting arrows on fence posts and checking whether bridges could hold the weight of military trucks. Eisenhower signed up partly for a lark and partly to learn. He would get both. The convoy departed the White House Ellipse on July 7, 1919. The first day covered 46 miles in 7.5 hours. That was one of the better days. The second day was delayed 2 hours because bridges along the route were either too wobbly to risk crossing or had covered roofs too low for the trucks to pass under. When the bridges could not be bypassed, the convoy simply drove through the rivers underneath them. In Illinois, the paved road ended. From there to California, the convoy crawled through dirt, sand, and mud that swallowed the trucks whole. The most valuable vehicle in the entire column was the Militor, a custom-built tractor truck with a power winch that cost the Army $40,000. It spent every single day towing stuck and broken vehicles out of ditches, mud holes, and sand pits. One evening, the Militor arrived in camp dragging 4 disabled trucks behind it on a single chain. In Nebraska, 25 trucks slid into a roadside ditch at the same time, including the Militor itself. A 200-yard stretch of quicksand outside North Platte cost the convoy 7 hours and 5 failed towing attempts before the last truck was pulled free. In Utah, the desert had not seen rain in 18 weeks. Trucks sank into dry sand up to their differential housings, and soldiers who had never done manual labor in their lives hauled them out by sheer muscle. The official War Department report recorded 230 motor accidents over the course of the trip. 21 men were injured seriously enough to be removed from the convoy entirely. 62 days after leaving Washington, the column reached San Francisco, having covered 3,251 miles at an average speed of 6 miles per hour. The War Department's conclusion was blunt. The existing roads of the United States were absolutely incapable of meeting present-day traffic requirements. Eisenhower never forgot that summer. He wrote about it in letters, in official reports, and eventually in his memoir. 25 years later, as Supreme Commander of Allied forces in Europe, he saw what good highways could actually do. The German Autobahn network, designed in the 1930s under the direction of Fritz Todt, was a system of 4-lane, limited-access highways that allowed military convoys to move across the entire country at speeds the 1919 convoy could not have dreamed of. Eisenhower watched American armored divisions use those highways to cross Germany in days instead of months. He later wrote that the old convoy had started him thinking about good 2-lane highways, but Germany had made him see the wisdom of broader ribbons across the land. When Eisenhower became president in 1953, he carried both experiences into the White House. the 6-mile-per-hour nightmare of 1919, and the German highways that helped win a war in 1945. His grand plan for a national highway system went to Congress in 1954, but the political reality was more complicated than the vision. Eisenhower's preferred version of the bill, authored by a committee led by retired General Lucius Clay, proposed funding the entire system through bonds issued by a new government corporation. Congress rejected it overwhelmingly in 1955. Eisenhower had adamantly refused to support any bill that raised user taxes or increased the federal deficit. But the bill that eventually passed was written almost entirely by congressional Democrats who did exactly that. Senator Albert Gore, Sr. of Tennessee, Representative George Fallon of Maryland, Senator Dennis Chavez of New Mexico, Representative Hale Boggs of Louisiana. Their version established the Highway Trust Fund, financed by increasing the federal gasoline tax from 2 cents to 3 cents per gallon, with additional new taxes on diesel fuel, tires, and heavy truck components. It was a pay-as-you-go system. Every dollar that went into the trust fund came from the people and businesses that used the highways. On June 29, 1956, the Senate voted 89-1 in favor. Senator Russell Long of Louisiana cast the only dissenting vote because he opposed the gas tax increase. The House approved the bill the same day by voice vote. Eisenhower signed the Federal Aid Highway Act into law while recovering from abdominal surgery at Walter Reed Army Hospital. There was no ceremony. There was no ribbon to cut. The first project to break ground under the new act was improvements to Interstate 70 in St. Charles County, Missouri. Construction began almost immediately across the country, and the machines followed. Like and subscribe if you want to see more stories about the machines that built America. The scale of what Congress had authorized is still difficult to comprehend, even 70 years later. 41,000 miles of controlled access highway connecting every major city in the country, and 90% of all American cities with populations over 50,000. 54,663 bridges carried the highway over rivers, railroads, and other roads. 104 tunnels bored through mountains and under rivers. Nearly 15,000 interchanges where highways met and separated again. The original authorization was $25 billion, which equals roughly $220 billion in today's money. The federal government would pay 90% of every project, and the states would cover the remaining 10%. Congress expected the system to be completed in 13 years. It took 35. But the number that matters most for this documentary is 42 billion cubic yards. That is the total volume of earth that was excavated, hauled, placed, and compacted during the construction of the interstate system. To put that in perspective, the Panama Canal project moved 96 million cubic yards of earth in 10 years and was considered the greatest engineering achievement of the early 20th century. The interstate moved more than 400 times that amount. It is the largest earth-moving project in the history of the human race. The construction consumed 1 billion pounds of explosives for rock blasting alone, 1.5 billion metric tons of aggregate for road base and concrete, 48 million metric tons of cement, 35 million metric tons of asphalt, 6 million metric tons of steel reinforcing bar and structural steel. And the machine that moved the greatest share of those 42 billion cubic yards was the wheel tractor scraper. The 1960s were what equipment historians call the decade of the monster machines, and the interstate highway system was the reason. The wheel tractor scraper was the dominant earth-moving tool on highway projects because no other machine could match its combination of speed, capacity, and self-loading capability. A fully loaded Caterpillar 631 weighed more than 50 tons and carried 31 cubic yards of material at speeds up to 30 miles per hour. The tandem-powered Caterpillar 637 added a second engine mounted behind the bowl, a Cat C 9.3 producing 290 horsepower, giving the machine a combined output exceeding 570 horsepower and even better traction in difficult loading conditions. Unlike a bulldozer, which can only push material over short distances, or a dump truck, which needs a separate machine to load it, a scraper performs the complete earth-moving cycle by itself. The hardened steel cutting edge slices into the ground as the machine moves forward. Soil flows up over the edge and into the bowl. When the bowl is full, the apron closes and the scraper hauls the load at highway speed to the fill location, where the operator raises the bowl floor and ejects the material in a controlled layer at whatever thickness the project engineer has specified. One machine doing the work that would require 4 separate machines in any other configuration. On a major interstate job site during the peak construction years, it was common to see 30 or 40 scrapers running in a continuous loop, side by side, but offset slightly to avoid cutting in each other's tracks. They operated around the clock in 2 12-hour shifts. The scraper operator sat in a cab that in the 1960s had no air conditioning, no pressurized enclosure, and no sound insulation. Dust, heat, noise, and the constant vibration of the cutting edge dragging through soil were simply part of the job. Every loading pass required precise coordination with a push tractor, usually a Caterpillar D8 or D9 crawler bulldozer that pressed its blade against the rear push block of the scraper to give it the additional traction needed to fill the bowl in anything harder than loose sand. A skilled push-cat operator could reduce a scraper's loading time from over 20 seconds to as little as 12 seconds. A clumsy one could stall both machines in the cut and shut down the entire loop. The working relationship between scraper operators and push-cat operators was the most important human dynamic on any interstate earthwork project, and veteran operators often refused to work with partners they did not trust. The scraper arms race of the interstate era was a direct continuation of the competitive war between R.G. Letourneau and Caterpillar that reshaped the entire earth-moving industry in the 1950s. Letourneau had dominated scraper production through the 1940s with his Tournepull motor scrapers and cable-controlled carry-all pull scrapers. His factories produced 70% of all Allied earth-moving equipment during World War II, a fact that still astonishes historians. But in 1953, Letourneau sold his entire conventional earth-moving division to the Westinghouse Air Brake Company for $31 million and turned his engineering attention to electric drive machines powered by planetary motors built directly into the wheel hubs. Caterpillar immediately moved to fill the vacuum. The company had already been developing its own integrated wheel tractor scraper, starting with the DW21 model in the early 1950s. The DW21 replaced the older system where a Caterpillar crawler tractor pulled a separate Letourneau scraper bowl on a drawbar. The new machine combined tractor and scraper in a single articulated unit, ran on rubber tires instead of steel tracks, and replaced the complicated cable controls with hydraulic cylinders that any operator could learn to use in days instead of weeks. The DW21 became the 631 series, and the 631 became the standard scraper of the interstate era. The scrapers did not work in isolation. Every interstate project was an ecosystem of machines working in a carefully sequenced chain, and if any link in that chain broke down, the entire operation stopped. Caterpillar D8 and D9 crawler bulldozers led the way, clearing the right-of-way through forests, farmland, and sometimes entire neighborhoods. The D9 was the largest standard production bulldozer Caterpillar manufactured at the time, weighing more than 49 tons and carrying a blade nearly 16 feet wide. A D9 on a 12-hour shift could clear a quarter-mile of interstate corridor through moderate terrain, pushing down trees, demolishing structures, and ripping stumps from the ground with a rear-mounted ripper shank. Behind the bulldozers came the scrapers, cutting and hauling the earth needed to build embankments over valleys and fill depressions to the designed grade. Behind the scrapers came the motor graders, arguably the most precision-demanding machines on the job. Caterpillar and galleon graders trimmed the subgrade surface to the exact contours specified in the engineering plans. The Galleon Iron Works Company, founded in Ohio in 1907, built some of the most respected graders in the industry. The Galleon T700, introduced in 1955, was the world's largest motor grader, producing 190 horsepower and weighing more than 40,000 pounds. It featured the first power shift transmission ever installed in a motor grader, which Galleon called the Grade-O-Matic drive. The Interstate design standards left no room for error. Every lane was exactly 12 feet wide. The right paved shoulder measured 10 feet. The left shoulder measured 4 feet. Overhead clearance was set high enough to accommodate military convoys, a direct echo of Eisenhower's original defense justification for the system. These were not guidelines. They were federal requirements enforced by on-site inspection, and the grader operators who trimmed the subgrade to those tolerances were among the most experienced and highly paid equipment operators on any project. The Interstate did not only transform how Americans traveled, it fundamentally restructured how goods moved across the country, and that restructuring created even more demand for the very machines that were building the roads. Before the Interstate, long-distance freight moved primarily by railroad. Trucks handled local deliveries and short hauls, but they could not compete with trains over distances exceeding a few hundred miles because the roads were too slow and too unreliable. The Interstate eliminated that disadvantage almost overnight. A tractor-trailer rig could now cross the country on a smooth, grade-separated highway at a consistent 55 miles per hour with no railroad crossings, no traffic lights, and no two-lane bottlenecks through small towns. The trucking industry responded by growing faster than any transportation sector in American history. Between 1956 and 1980, the number of registered commercial trucks in the United States more than doubled, and every mile of highway those trucks drove on had to be engineered to handle their weight, which meant thicker pavement, stronger bridges, wider lanes, and more earthwork to maintain the gentle grades that loaded 18-wheelers required. The machines building the Interstate were simultaneously creating the commercial demand that justified building even more Interstate. It was a cycle that fed itself for 3 decades. Like and subscribe to follow the full story of how the Interstate changed the equipment industry forever. The men who operated these machines worked in extreme conditions that would be unrecognizable to a modern equipment operator. In the early 1960s, scrapers and bulldozers had open cabs with no rollover protection structures, no seat belts, and no climate control of any kind. In summer, operators in Arizona and Texas sat in metal seats above diesel engines that radiated heat upward while the sun baked them from above. Temperatures in the cab could exceed 130 degrees Fahrenheit. In winter, operators on interstate projects in Minnesota and Wisconsin wrapped themselves in surplus army blankets and kept thermoses of coffee wedged between their legs to stay warm. Dust was so thick on some projects that operators tied bandanas across their faces and could not see the scraper ahead of them in the loop. Hearing protection did not exist. A D9 bulldozer at full throttle produced noise levels that caused permanent hearing damage within hours, and many interstate-era operators spent their later years profoundly deaf. The contractor workforce on interstate projects was enormous. At the peak of construction in the early 1960s, more than 200,000 workers were employed simultaneously on interstate job sites across the country. These were not government employees. Each state highway department awarded contracts to private construction firms, who hired their own operators, laborers, and supervisors. Some of the largest contractors of the era built their entire companies on interstate work. Peter Kiewit's Sons of Omaha, Nebraska grew from a regional builder to a national powerhouse by winning highway contracts across the western United States. Morrison Knudsen of Boise, Idaho, which had previously built dams and military installations, pivoted to interstate work and expanded dramatically during the 1960s. These companies purchased thousands of scrapers, bulldozers, and graders, and when the interstate work eventually slowed, they found themselves with fleets of specialized machines that had no other projects large enough to absorb them. The hauling fleet on interstate projects included machines whose names defined an entire era of construction. Euclid trucks from Cleveland, Ohio, were among the most common sights on interstate earthwork. By the mid-1950s, Euclid manufactured more than half of all off-highway dump trucks sold in the United States, and the construction industry had adopted the word UCIR as a generic term for any off-highway haul truck, regardless of manufacturer. We told the full Euclid story in our Lost Giants series, covering the Armington family that founded the company in 1907, the Model 1Z track truck that created the off-highway dump truck category in 1934, and the disastrous General Motors acquisition in 1953 that triggered 8 years of antitrust litigation. The Department of Justice forced General Motors to divest half the Euclid product line in 1968, and the forced split created Terex while leaving both companies weakened. Neither ever regained the dominance that Euclid had held before the government intervened. One of the most consequential events of the entire interstate era took place not on a construction site, but on a purpose-built test track outside Ottawa, Illinois. From 1958 to 1960, the American Association of State Highway Officials ran the AASHO road test, the largest controlled pavement research program ever conducted anywhere in the world. 6 loops of test pavement were constructed using varying thicknesses of concrete and asphalt over different base materials. Trucks carrying calibrated axle loads then drove those loops continuously, 24 hours a day, 7 days a week, for 2 full years. Engineers measured every crack, every rut, every surface depression with instruments that recorded the exact progression of damage under each loading condition. Before the AASHO road test, highway engineers designed pavement thickness largely by experience. After the test, they had mathematical equations derived from millions of load repetitions on controlled surfaces. Those equations determined how thick every mile of interstate pavement would be built, and updated versions of the same formulas are still used to design highways today. Every road you drive on carries the DNA of that test track near Ottawa. The paving operation itself required an entirely separate family of machines. Slip-form concrete pavers were among the most important technological advances to emerge from the interstate construction program. Traditional concrete paving used fixed steel side forms bolted into position along both edges of the lane. Workers poured concrete between the forms, consolidated it with handheld vibrators, screeded and finished the surface by hand, and then waited for the concrete to cure before stripping and repositioning the heavy forms for the next section. It was brutally slow work. Slip-form pavers eliminated the fixed forms entirely. These machines rode on crawler tracks alongside the fresh concrete, carrying their own internal forming and finishing system. Concrete from mixer trucks was deposited into a receiving hopper at the front of the machine, spread across the full lane width by a horizontal auger, consolidated by banks of internal vibrators, and extruded through a carefully shaped forming section as a continuous finished slab. A single slip-form paver and a crew of 6 operators could lay a lane of interstate-grade concrete faster than 50 men could accomplish with fixed forms and hand tools. Approximately 60% of the original interstate system was paved with Portland cement concrete, particularly in urban corridors and on routes carrying heavy commercial truck traffic where long-term durability outweighed the higher upfront cost. The remaining 40% used hot mix asphalt, laid by machines built by companies like Barber Green of Aurora, Illinois. Barber Green had been building road construction equipment since 1916 and was one of the pioneers of the continuous asphalt paving machine. Their pavers received hot mix asphalt from dump trucks at the front, spread it across the lane width through a heated screed, and compacted the initial layer as the machine crept forward at walking speed. Behind the paver came a procession of steel drum and rubber-tired rollers that compressed the asphalt to its final density while it was still hot enough to flow. The entire paving train, from the first truck dumping into the paver hopper to the last roller making its final pass, could stretch a quarter mile along the highway. In northern states, where frost heave and freeze-thaw cycling could destroy thin pavements in a single winter, road sections were built up to 5 feet thick from the base layer to the finished surface. The material quantities were staggering: 1.5 billion metric tons of aggregate, 48 million metric tons of cement, 35 million metric tons of asphalt binder, and 6 million metric tons of steel. Some sections of the interstate pushed construction engineering to its absolute limits. The Eisenhower Memorial Tunnel on Interstate 70 in Colorado is the highest vehicular tunnel on the interstate system, sitting at 11,158 feet above sea level. Construction of the first bore began in March 1968, and the challenges started immediately. Workers excavated 524,000 cubic yards of rock at an altitude where thin air reduced the output of both diesel engines and human lungs by 30% compared to sea level. 1,140 people worked in 3 rotating shifts, 24 hours a day, 6 days a week. The mountain fought back constantly. Geologists had predicted where stress fractures would appear based on standard rock mechanics theory, but the Continental Divide did not read the textbooks. Unexpected pressure zones crushed support timbers. Water infiltration flooded working faces. Engineers had to develop new excavation methods to mine and reinforce a bore 50 feet high and 45 feet wide through rock that squeezed, shifted, and fractured in patterns that defied prediction. Contractors poured 190,000 cubic yards of concrete to line the tunnel, used 34,000 cubic yards for the portal buildings, installed 10,000 tons of steel rebar, and erected 23,400 tons of structural steel. 7 workers lost their lives building the 2 bores. The first tunnel opened on March 8, 1973. The second bore, later named the Edwin C. Johnson Tunnel, followed in December 1979. Like and subscribe if this story is giving you a new perspective on the roads we drive every day. Glenwood Canyon on Interstate 70 in western Colorado was considered by many to be the single most technically challenging section of the entire 41,000-mile system. The canyon runs 16 miles between sheer rock walls on both sides of the Colorado River. The space between the cliffs was already occupied by the river, a Denver and Rio Grande Western Railroad line, and a narrow 2-lane road. Adding a 4-lane interstate through this canyon required engineering solutions that no previous highway project had ever attempted. Kiewit Construction Company, which had grown from a local Omaha builder into one of the largest highway contractors in America partly through decades of interstate work, deployed up to 500 workers on the Canyon project, beginning in 1981. Environmentalists and scenic preservation advocates demanded design features unprecedented in interstate construction. Engineers responded with 40 elevated viaduct sections that carried the highway above the river on concrete pillars, avoiding disturbance to the riverbed. Where the cliffs left no room for an open road, tunnels were bored directly through the rock. Retaining walls were built into the canyon face, and their surfaces were textured to match the surrounding stone, so the highway would blend into the landscape, rather than scar it. The result was the most expensive section of interstate ever constructed on a per-mile basis. and it was not completed until 1992, making Glenwood Canyon one of the final pieces of the original system to open to traffic. Between 1957 and 1977, the highway program required the demolition of approximately 475,000 structures to clear the rights-of-way. Over 1 million Americans were displaced from their homes. Route planners consistently selected corridors through neighborhoods where land acquisition costs were lowest, and in city after city, that calculation fell on communities of color. In Miami, Interstate 95 cut through the historically black neighborhood of Overtown, reducing the population from roughly 40,000 to 8,000. In Chicago, the Dan Ryan Expressway was routed to form a physical wall separating the Robert Taylor Homes public housing project from white ethnic neighborhoods to the west. The 90% federal funding share that made the interstate possible also insulated decision-makers from local accountability. The communities that lost everything had almost no say in where the roads went. The machines did not choose their targets. A Caterpillar D9 does not know the difference between a pine forest and a family home. The operators followed survey stakes. The surveyors followed engineering plans. The engineers followed political decisions made in state highway department offices. The destruction was systematic, thoroughly documented, and carried out by the same machines that built the highways themselves. But the interstate destroyed something else that gets even less attention than the neighborhoods. It consumed 3 of the 4 companies that built it. Of the 4 manufacturers that held roughly equal shares of the American earth-moving market in the 1960s, only Caterpillar survives under its own name today. We documented the Alice Chalmers collapse in our Lost Giants series. It was a $6 billion industrial empire that expanded into too many product lines, lost competitive focus in construction equipment, and was ultimately broken apart and sold for scrap. By 1999, the name itself was dissolved. We documented Euclid and the antitrust catastrophe that split the company in 2. Leaving both halves too weak to compete independently. Euclid passed through 8 owners in 4 countries before the name disappeared entirely. International Harvester lasted longer than the others, but a devastating 6-month labor strike in 1979 and a crushing debt burden forced the company to sell its entire construction equipment division to Dresser Industries in 1982. Dresser later merged with Komatsu to form Komatsu Dresser. The International Harvester construction equipment brand vanished from job sites forever. Caterpillar survived because of 3 structural advantages that none of its competitors could match. First, Caterpillar operated the deepest independent dealer network in the world. When a scraper breaks a hydraulic hose on an interstate job site at 2 in the morning, the company that delivers a replacement part by sunrise wins the next contract. Caterpillar's dealers provided that level of service consistently. Second, Caterpillar transitioned from cable-controlled machinery to fully hydraulic systems faster and more aggressively than any competitor. The hydraulic technology that killed Letourneau's cable scrapers in the 1950s became the foundation of Caterpillar's product line in the 1960s and the 1970s. Third, Caterpillar had been designing and manufacturing its own diesel engines since 1931, when C.L. Best's engineering team introduced the Diesel 60 at the Stockton, California factory. By the Interstate era, every Caterpillar scraper, bulldozer, and motor grader ran on a purpose-built Caterpillar diesel engine. Competitors who purchased engines from outside suppliers like Cummins or Detroit Diesel paid more per unit and exercised less control over their supply chains. When the interstate construction boom faded and profit margins tightened in the 1970s and the 1980s, that cost difference became a matter of corporate survival. The interstate also accelerated a technology shift that permanently changed which machines dominated the construction industry. Before the interstate, the wheel tractor scraper was the undisputed tool of choice for large-scale earth-moving. After the Interstate, the hydraulic excavator and the articulated dump truck steadily replaced the scraper on more and more types of projects. Hydraulic excavators first appeared in the 1950s and gained real commercial traction through the 1960s and the 1970s. The successful pairing of a hydraulic excavator loading an articulated dump truck proved to be cheaper and more versatile than a self-propelled scraper fleet in most soil conditions. Articulated trucks did not require carefully graded haul roads. Excavators did not need push tractors. The combination worked in tighter spaces, on steeper slopes, and in wetter ground. By the 1990s, the excavator and truck system had displaced scrapers from the majority of earth-moving applications. The scraper killed the horse-drawn Fresno scraper, and the excavator killed the scraper. That is how progress works in this industry. Every generation of machines builds the world and then gets replaced by the next. Today, the interstate highway system carries approximately 1/4 of all vehicle traffic in the United States on roughly 1% of total road mileage. The network includes more than 48,000 miles of highway, over 55,000 bridges, and more than 100 tunnels. The longest single route is Interstate 90, running 3,020 miles from Seattle, Washington, to Boston, Massachusetts. Fatality rates on the interstate remain less than half those on non-interstate roads, a direct legacy of design standards that eliminated traffic lights, intersections, and opposing lanes from the system. The machines that built it are mostly gone. Scrapers were parked in rows when the major earthwork contracts dried up, and most were eventually cut apart for salvage steel. Bulldozers wore through their final set of undercarriage components and were traded in or scrapped. Graders went to smaller contractors or were shipped overseas. A few interstate-era machines survive today in museums and private collections. The Historical Construction Equipment Association in Bowling Green, Ohio, preserves several of the 1960s Caterpillar 631B motor scrapers, and members of the Antique Caterpillar Machinery Owners Club maintain working D8 and D9 bulldozers that once cleared the first right-of-way cuts through American forests and neighborhoods. This is one of the most overlooked stories in construction history, and we spent weeks pulling the research together because we believe it deserved to be told from the perspective of the iron and the operators, not the politicians. Everyone knows the interstate changed how America lives. Almost no one knows it also consumed 3 of the 4 largest equipment manufacturers in the country, ended the dominance of the scraper as the primary earth-moving machine, and left behind a trail of obsolete iron stretching from coast to coast. The next time you merge onto the interstate and accelerate to 65 miles per hour without encountering a single stoplight, remember that a 28-year-old Army officer once spent 62 days crawling across the same country at 6 miles per hour. Remember the scraper operators who ran continuous loops for 15 years straight. And remember that the 42 billion cubic yards of earth, the billion pounds of explosives, and the 3 American companies that gave everything to build those roads did not survive to see the project finished. Like and subscribe for more stories about the machines that built America.